The stage. What? What is how to make it a presentation work?
No, this one is PowerPoint, so we can't do that. But you have to give me yours hours to office.
How to do so? Where is this?
You want to do what you want to do? Concepts. The only problem is that this email.
No? You don't have to.
You couldn't. No, they can't
You
do
have
it.
it on the computer.
Yeah.
I have a USB.
I have used it, but it's not connecting.
So maybe
Can you connect to my email also, or you can connect?
you have your computer, right?
Yeah.
Two slides. So we'll start our session, and our first presenter be made by Aman. Aman, please. Okay, the floor is yours.
Thank you. Hello everyone, I'm Aman. Today I'm going to present my master thesis titled Temporal Dynamics of Tree Species Composition in the Spanish Iberian Range, Insight from National Forest Inventory and Satellite Data. So let's start with the introduction. Forests in the Mediterranean region are rapidly changing, mainly due to the combination of climate change and human intervention. And historically, these forests were managed as a monospecific forest, but in recent time, there has been shift in this management model toward the mixed forest, mainly due to the multifunctional nature of these forests, like resilience, broader biodiversity, or broader socioeconomic benefits. So it's really important to uncover these long-term changes in this region. So for this, we need a long-term temporal data sets. So for this, Spanish National Forest Inventory provides forest information spanning more than 3 decades. And also, an additional key question we would like to explore in this our work is, can we assess these temporal changes with the satellite data, especially Landsat time series data? So based on this context, our first objectives is to assess recent temporal changes in tree species composition in the forest using 3 available cycles of SNFI plot data combined with 4 decades of Landsat derived spectral index time series, specifically to characterize species dynamics within permanent SNFI plots spanning more than 3 decades, and also to evaluate the spectral separability of different forest types using long-term seasonal spectral index data from Landsat imagery. So for our work, we carried out our study in the ecological unit of Northern Iberian Range, covering full administrative boundary of Burgos, La Rioja, and Soria. So first, we defined the forest at the plot level from the plots of 3 cycles of the Spanish National Forest Inventory, 2nd, 3rd, and 4th, based on the basal area dominance. So if single species comprise more than 75% of the total basal area in the plots, we classify that plot as a pure forest. And if no species or any species fail to do so, we classify that species as a mixed forest. And also we extend these forest classes to conifer and different types of broadleaf like evergreen, marchescent, and deciduous. So this is our schematic workflow of method. So for the input, we have mainly 2 databases, SNFI databases and Landsat images. So with the SNFI databases, first we retrieve all the permanent plots that was measured in all the 3 cycles of inventory, and we use R to analyze to see the specific dynamics across SNFI. And with the Landsat images, we retrieve seasonal spectral index, especially enhanced vegetation index, we using Google Earth Engine, and following analysis was carried out with R, especially parametric and non-parametric ANOVA, to see the spectral separability among forest types. So going detail how we extract the data with the Google Earth Engine. So we retrieve mean, seasonal, enhanced vegetation index EVI for 4 seasons: winter, spring, summer, and autumn, with Landsat images 5, 7, and 8 for the time period 1986 to 2018, making it equivalent to the time frame of the 3 cycle of national inventory. And we also, to ensure the consistent data sets, we perform harmonization, especially in the Landsat 8 data set, and we also maxed out cloud, shadow, and snow images, and also we constrained our index range from 0 to 0.9 to represent the vegetation. And so we assess the species dynamics in total 2,821 permanent plots, and we assess the dynamics of pure and mixed stand. We assess species responsible for the transition from pure to mixed stands. And for the seasonal spectral analysis of the forest types, we chose 6 pairs of different pure and mixed forests. And first, we performed the check for assumption with Shapiro-Wilk test for normality of residuals, and also with diagnostic plot, histogram, QQ plots. And for the homogeneity variance, we choose Levin test. And based on the results from this check for assumption, we perform one-way ANOVA and post hoc pairwise comparison with Tukey HSD for winter season, and Wells ANOVA and post hoc comparison Games OWL for the other season. So, at first, starting with the overall species dynamics across 3 cycles of SNFI, we observe notable shifts in mixed forests, nearly doubling of the coverage from 2nd cycle to 4th cycle, from 12% to 23%, whereas in pure forest we see consistent decline from 87% to 76%. And with the extended classes of pure and mixed stand, we observe notably higher increase in especially mixed conifer and broadleaf species. And upon checking the transition of these pure and mixed plots, we observe that around 12.4% of the total permanent plots has been transitioned from pure to mixed stand. In contrast, only 2.72% has been transitioned to pure from the mix. So, considering the only plots that has been transitioned from pure to mix, the main species that are driving this transition were found to be Quercus ilex with 26.29%, followed by Quercus faginia, Quercus pyrenaica, and also some conifer species like Pinus sylvestris, Pinus pinaster, and at the least being Ilex equifolium. So with the pairwise comparison of 6 different types of forest pairs, we observe there has been clear spectral separability between many pairs, especially the 3 pairs like pure conifer, pure deciduous, and pure conifer and pure mixed conifer and deciduous, pure evergreen and mixed conifer and deciduous, whereas in some pairs we didn't see quite the separability except for only one season, like pure conifer and pure evergreen, and pure deciduous and mixed conifer and deciduous. So to conclude, we have seen the clear transition from monospecific forest to mixed specific, nearly increased by 12%, and also in mixed forest we observed that the mixed conifer broadleaf was increased higher as compared to other mixed forests, and also the species responsible was for Quercus ilex, Quercus faginia, and Pinus sylvestris. And the implication and the next step of this work would be to integrate SNFI growth metrics like basal area, biomass volume, and regeneration data to assess functional impacts, and also investigate drivers behind these species composition shifts. And from the insights of the remote sensing part was that long-term EVA time series enable spectral discrimination between pure and mixed forest types, and peak phenological contrast drives separability, especially in summer, shows the highest separability, and the limitation is Landsat resolution constraints the detection of subtle or mixed stand, and also the cloud cover and phenological similarity reduce spectral severability. Thank you.
Okay, we thank you, Aman, for your insights. So I invite our second presenter, Jorge. Okay, the floor is yours.
Thank you for introducing me. I will show results from part of a project analyzing current and future condition of forest species in the Iberian Peninsula. Forest species are likely to shift their spatial distribution due to climate change, and forecasting future distribution patterns is essential for a sustainable forest management. This work is part of the ECO24 project, which aims to integrate climate change adaptation into strategies into forest-based carbon sequestration projects by identifying the most suitable tree species under future climate scenarios. For this, we have used species distribution models. The general aim is to model future suitability of main forest species under 3 climatic scenarios, and specifically, we aim to map current and future suitability, to quantify potential change, and to provide recommendations for species selection in forest carbon sequestration projects. Species distribution models establish a statistical relationship between known species occurrence and the environmental conditions that explain them, allowing us to project future suitability under different climate scenarios. The workflow to generate species distribution models has 4 main steps. First, the collection and processing of species presence from the Third National Forest Inventory. A total of 34 models were developed, covering genera such as Pinus, Quercus, Fagus, Juniperus, Betula, Olea, among others. And second, the acquisition and processing of environmental variables. A total of 32 variables were considered: bioclimatic, topographic, soil pH, and solar radiation. And for the variable selection for each species, correlated variables were removed. Variable importance was assessed using training models, and random combination of predictors were tested. And models were selected based on variable importance and AUC values. The third step, calibration and validation models. We have used Maxent, a presence-only method using automatically generated background points, or also known as pseudo-absence, to characterize the environmental space. Data was split into calibration and validation sets, and it generates a continuous suitability value interpreted as the probability of potential presence for each pixel. And the fourth step, the spatial and temporal projection of the model under different climatic scenarios. The cutoff between present and absence was chosen to balance correctly predicting positives and negatives, and we assessed model performance with the AUC, which measures how well the model separates presence from absence. The EPC scenarios range from low emission pathways to very high emission pathways, and the time periods were the reference period or present, and short, mid, and long term. The models show high predictive ability. The observed patterns are consistent with species ecology, and change increases with higher emission scenarios and longer time horizons. The management implication is prioritize resilience and adaptation. Respect to Mediterranean species, are strategic species for adaptive reforestation. Mediterranean species show high stability or slight expansion under moderate scenarios and slight long-term reductions under extreme scenarios and shifts to the north and to higher elevation, like for example Quercus ilex. Another example of Mediterranean and Thermophilus species as all Europea shows sustained expansion under all scenarios and shifts to the north. This map represents future conditions being analyzed and classified as gain, stable, loss or absence relative to the current period, and we present the intermediate scenario along with the three temporal periods. Respect to Mediterranean species, show some short-term stability, progressive and severe long-term decline, and shift to the north and to higher elevations like Quercus pyrenaica. And another example of submediterranean species like Quercus vaginea is the more resilient submediterranean species with a slight long-term reduction under extreme scenarios and also shift to the north and to higher elevations. And finally, respect to Euro-Siberian species like Pinus sylvestris or Fagus sylvatica, in this case we show Pinus sylvestris, with some short-term stability, progressive and severe long-term reductions, and shift to the north and to higher elevations. Species distribution models allow anticipating climate change effect on our forest. The observed responses, Mediterranean and Thermophilus species resilient and with partial expansion, Submediterranean species and intermediate vulnerability, Euro-Siberian species highly sensitive, contraction and isolation, and the general trend is altitudinal and latitudinal shifts toward colder and wetter areas. And there are direct implications for forest management and carbon sequestration projects as integrate climate adaptation into planning, select resilient species, and design adaptive and preventive management to respond to future climate variability. And that's all. Thank you.
Thank you, Joaquin. So our next speaker will be Lucia.
Hold the screen.
Okay, thank you.
Thank you.
Over to you.
Okay, thank you. So, good morning everyone. My name is Lucia Alonso Villar. I'm a PhD student at the company IDEFOREST, and today I'm going to present you the work entitled Assembly of Xylem Inhabiting Bacterial Communities for Sustainable Management of Olive Vascular Diseases, which was carried out at the Institute for Sustainable Agriculture of CSIC in Córdoba. So, a bit of a background, diseases caused by Verticillium daliae and Xylella fastidiosa are vascular diseases that affect a wide range of woody plants. In the case of Verticillium daliae, it's a soil-borne fungi that can infect over 70 host plants, and its mycosclerotia can remain viable in the soil for up to 14 years. Meanwhile, Xylella fastidiosa, it's a xylem inhabiting bacterium regulated by the European Union as a quarantine pest, and it's transmitted by insect vectors. It can affect over 700 host plants, and both diseases have in common that they colonize the xylem, and the symptoms that the plant develop are really similar, and also similar to severe drought. Both of them cause high economic and environmental impact, and right now the control measures are partially effective as they are focused on eradication and containment. Therefore, there is an urgent need for integrated management to prevent the spread, reduce the incidence and the severity of these pathogens. Plant vascular diseases cause important cultural, social and environmental effects other than the more evident economic ones. And one of the most affected species is the olive, Olea europaea, which is a key component of Mediterranean agroecosystems. Spain holds the first global producer according to FAO, and this crop occupies over 52% of the total goody crop area in Spain, almost 16% of the crop area, and more than 5% of the total geographical area of Spain. And as Jorge just mentioned, it's a expanding species, so we expect it to cover even more during the next years. So in this challenging context, endophytes are emerging as a promising strategy because they have mechanisms related to biocontrol for these diseases. There are two types of mechanisms related with biocontrol. Direct mechanisms are related with inhibition and enzyme production, and indirect mechanisms are related with plant growth promoting traits. So we hypothesized that we could develop bacterial synthetic communities of these endophytes with mechanisms related with biocontrol to try to control these diseases. So the objectives that we set was to develop syncoms using olive xylem inhabiting bacteria with biocontrol potential against these two vascular pathogens. And to reach this goal, we developed the following workflow, starting with the isolation of a bacterial collection of over 300 strains. Then we selected the 105 representative ones to evaluate their direct and indirect biocontrol mechanisms. Then, with the 26 most promising strains, we evaluated their metabolism profile by carbon sources assimilation, biochemical sensitivity, and pathogen in vitro inhibition. And then we performed compatibility assays to finally be able to select the ones to design the syncom. So, starting with the evaluation of direct and indirect biocontrol mechanisms, we performed 18 different assays, 5 of them related with plant growth promoting mechanisms, which are the indirect ones, and the remaining 13 with the enzyme production and direct mechanism. Most positive results, as you can see in the pictures, are shown with a transparent halo, a change of color to red or blue, bubble formation, precipitate formation, or the turn to brown color in the filter paper. Then, with the 26 most promising ones, we evaluated their carbon sources assimilation using Biologen 3 microplates, which have 71 carbon sources lyophilized into the wells and 23 biochemical sensitivity assays. And then, with those same 26 strains, we performed dual cultures with the pathogen isolated as alone and the tested strains with droplets. And then we performed compatibility assays. The compatibility assays allowed us to discard the more incompatible ones shown in red, and taking into account these results, along with the complementarity into biocontrol mechanisms, the in vitro inhibition, we selected 5 promising strains to assemble the 2 syncoms. Also, we confirmed the syncom performance against the pathogens to be consistent with the one showed with the individual strains. And right now, we are testing the 2 syncoms that we've developed in tobacco plants as a model plant and also Olea europaea. These experiments are currently ongoing, but preliminary results look really promising. And as take-home messages, I want to highlight that we characterize a diverse collection of olive endophytes with biocontrol potential against vascular pathogens. The selected strains showed compatibility, supporting the development of effective synthetic communities, and preliminary implanted results are promising, encouraging further experimentation under field-like conditions. And overall, this work provides a foundational step towards sustainable microbiome-based strategies for olive crop protection. I want to thank the Biology and Ecology of the Soil Microbiome Group at the IASTESIC, all the funding from national, regional and international projects, some collaborators and the grant from Agencia Estatal de Investigación. And also thank you all for your attention.
Thank you, Lucia, for your slides. So I now invite Taira. Sorry. Over to you.
Okay, good morning everyone. I'd like to start by asking a question, and that is, what do we see in these images? I know that it's early, so I'm going to answer, I'm going to help. We see streets lined with trees. Studies have shown that this is good for mental health, it improves the urban heat island effect, and trees are even able to reduce the concentrations of pollutants from their environment. But there's something else that we can see in these trees, or in these images, and that is that in every street, the same species of tree is planted. And that's going to be the topic of my discussion today. My name is Tiara Zimmerman. I'm going to be talking about the urban trees of Rotterdam and how we can optimize tree selection for public health and climate resilience. Trees are facing an increased risk of mortality due to climate change-induced drought events. The Netherlands alone faced 3 years of consecutive drought events at the time that I conducted this research, and last year's spring actually broke the record for the driest ever since 1976. So because of this, we have to change our patterns and approaches to how we plant trees in cities. This brought me to my research, which investigated tree selection as a means to optimize the removal of air pollutants known as phytoremediation, as well as investigating the effects of tree-to-tree interactions on drought resilience. I identified the main air pollutants in the greater area of Rotterdam. These were nitrogen dioxide, particulate matter 2.5, particulate matter 10, and ground level ozone. And data revealed that the concentrations of these pollutants in the urban areas of Rotterdam are only slightly below daily exposure thresholds. I identified the species of trees with superior phytoremediating abilities for these pollutants. These are shown in the corresponding boxes to the colors of the pollutants in the title. The numbers in brackets show how many individual trees of that species are planted in Rotterdam. I also conducted a drought tolerance assessment on these species and found that most of them are at least somewhat drought tolerant. This is to be expected because trees planted in urban areas are often selected for slight tolerance to drought, since they are planted underneath concrete or asphalt, which are impermeable surfaces that also give them a small root area available. The species in bold, however, were identified to be drought sensitive. Then, using QGIS, I mapped the general distribution of all the trees planted in the municipality of Rotterdam. That was a total of 190,400 individual trees. And although we saw in the first slide that the general trend is to plant in these monospecific tree lines, I had to first confirm that this was the case in Rotterdam. Here we see a zoomed in map of the center of Rotterdam. However, there's a selective filtering to display only the trees with superior phytoremediating abilities for those main pollutants. In yellow, and the yellow dots, we can see the species Platanus hispanica, hybrid, or the London plane, which is planted in the highest quantity in Rotterdam and mainly along the larger roads. And as we can see, the general pattern is to plant in these monospecific tree lines. Several studies were also assessed to compare the effects of species mixing on the drought resilience, or species mixing on the survival and the growth rate of trees before, during, and after drought events. And this was a big discussion on the round table yesterday, but I'm just going to briefly go over what I'd found, and that is that there are positive and negative species interactions. Positive interactions, maybe you recall from yesterday again, include resource partitioning, facilitation effects, and the selection effect, which is seen in the top image, often occurring between heterospecific neighbors or in mixed species plantations. In the image below, you can see an example of a negative species interaction between trees of the same species, showing crown shyness. This is in competition for canopy space, and again, you can see this is occurring between monospecific neighbors. Now I will go to the main findings of my research. The first main finding was that tree-to-tree interactions under drought conditions are highly complex and they're species-specific. They are dependent on factors such as tree age, their size, as well as the degree of the drought stress. However, it was also indicated that drought-sensitive species often benefited from having heterospecific neighbors in comparison to when planted in monospecific plantations. My second finding was that although the effects on individual species varied, overall increasing biodiversity could enhance community drought resilience. I would like to highlight and stress the importance of functional trait diversity, something that Hans from the Technical University of Munich was also speaking about, as a way to support positive tree-to-tree interactions. Air pollutant capture was also increased by trait diversity and diverse planting patterns on a vertical scale. Given the findings of my research, I would recommend this city of Rotterdam to transition away from scenario A, which is at the top left of the screen, towards scenario D. So moving away from these traditional monospecific tree lines that we have seen in Rotterdam Central towards a more diverse planting pattern with mixed species of trees with diverse functional traits. I'd like to thank you so much for your attention and thank you for your time. These are my references.
Thank you, Tara. Maybe we I was to invite. Maybe I think. Continue with others. Sorry for the technical later. So we continue with the next speaker, Sophia. Please go.
Hello everyone, my name is Sophia. I'm a Med4 student. Prior to that, I worked for the state of California managing a project called the Land Smart Grazing Program. So I'm going to be talking about how public funding can be used to support sustainable fire mitigation and also build community. How do I get to, there we go. Okay, so the problem that this project addresses is that since colonization, we've had the introduction of non-native, mostly annual invasive species that have displaced our native plants in California. This also has displaced our native disturbances as well, such as the use of fire and our native grazing like ungulates, such as elk and deer. So this has direct impacts on our species biodiversity. These lower pictures are yellow star thistle and harding grass. These are really invasive and problematic plants in California. And this top photo is a native perennial grass called meadow barley. This is what we'd like to see in our California rangelands. The consequences of this is we have an increase in fine fuel biomass. We have really hazardous ladder fuels, fuel continuity, higher flame lengths, and also fires are spreading quicker as well. As you probably already know, wildfire is a huge issue in California as well as in most Mediterranean ecosystems. This vegetation needs to be managed. Often landowners are legally mandated to as well, depending on where they live. And the options we have for managing this vegetation is prescribed burning, mowing, like mechanical operations, as well as herbicide. But these options aren't always popular with the general public. They can be really expensive. They're not always feasible depending on where the land is. And we need just a better option to manage vegetation on a landscape scale. So that's where the Land Smart Grazing Program comes in. We provide funding to landowners to help use grazing as a vegetation management tool. This program utilizes local and state grants to fund projects such as multiple landowners grazing in previously burned areas. So landowners that lost their homes in recent fires that have now had a lot of regrowth will fund projects to bring in a herd of goats or sheep or sometimes cattle. We also will pay for the installation of permanent grazing infrastructure, such as permanent perimeter fencing or water troughs. We provide community education on how to utilize this tool, and we also provide funding for our shepherds to increase their business's capacity. Why should we graze? Prescribed grazing mimics a natural and necessary disturbance that our ecosystems are adapted to. It also transitions our seed banks to a more native and perennial landscape. This top photo here shows like a perfect example of these hazardous ladder fuels. All of this is non-native, and these like mid-length fuels, that's all invasive shrubs that have resprouted after a wildfire. Also in the bottom photo, you can see this is right after a graze we did in the spring. It increases our biodiversity. We had one of our best wildflower years after we brought grazing back to this site. And it also, the manure increases soil fertility. So it's overall a great idea. More options or more reasons we should graze. Animals can access places humans or machinery can't. It's also a lot less noisy and less of an air pollutant than other options. Sometimes it's cheaper, and it also supports our local fiber and food systems. So this project here was in the middle of the American suburbs. We could run a lawnmower through here, but I don't think the community would like that as much as they would seeing a nice herd of sheep grazing. A lot quieter, a lot less carbon being used. So here are some previous project examples. This is a nature preserve that had a catastrophic wildfire go through it twice in the last 7 years. You can see 5 days post-grazing, there's been manure left over, there's been bare soil exposed. You can see the fire has gone through because the fencing is charred. And then one month post-grazing, we've had some resprouting, so we're increasing live fuel moisture greater into the dry season. And so also our perennial grasses are having a chance to compete with the non-native invasive annual species. This is the installation of permanent infrastructure. This is the same preserve. We have power lines going through. On the other side of this hill, we also have a water treatment facility that provides clean water to around 500,000 people. So we need fuel reduction and fuel mitigation around this area. And so we brought cattle into this preserve again. We also formed community grazing co-ops. This community lives adjacent to a state park, and we help them design a community grazing co-op so they all collectively share the cost of bringing a herd through their community year-round. So this is getting neighbors to think proactively about wildfire mitigation. Most of these people lost their homes in 2017, and this is giving them a chance to organize and recover and also utilize grazing as a tool. They also have birria nights at the end of each grazing season, so it's fun. This is another example, before versus after. You can see the reduction of ladder fuels, uplimbing, and also just fine fuel biomass has been decreased. This is right below that property, all invasive shrubs, after. We also fund the Transhumans Festival, where we run a herd of sheep through Petaluma in California. We're introducing this concept back to the general American public. You don't see something like this generally in California. So we herd a flock of sheep through town, and then we also provide educational demonstrations related to land stewardship practices. And it also gives people a chance to purchase local fiber products. The results of this project is we've invested nearly $1 million into rural communities. We've managed over 1,000 acres sustainably. Neighbors are working together. They're forming community through this. Local shepherds are getting recurring contracts, so they're able to increase their business's capacity and plan for the future. We've worked with 3 local governments to create long-term grazing plans for their open spaces they manage, and the general public is more aware of this as an option as well. And then I'll end on this photo. This is California poppies, as well as our state grass, purple needlegrass. You can see it's the middle of summer on this ridgeline, and it's the only thing that's green. So we're trying to increase the frequency of our native perennial grasses and bring them back. And we're also trying to use grazing, one, to increase public safety for fire mitigation, but also increase biodiversity, bring back our native forbs, such as on the right. So this is Cicerynchium bellum, western blue-eyed grass. Thank you for listening.
Thank you, Sofia, for your insights. So our next speaker will be Manuel. Also, please go ahead.
Hello everyone, good morning. My name is Manuel Crespo Corrillero. I'm going to talk about my project called Planning of Urban Green Infrastructure in the municipality of Villamuriel de Cerrato. This village is near to Palencia and no more than 39 square kilometer per area and no more than 6,000 inhabitants. The general objective of this project was to develop a green infrastructure strategic plan. For do this, we need to do another specific object like design a structure and replicable working methodology, develop a detailed inventory of green infrastructure, conduct a comprehensive assessment of the condition and functionality of this kind of infrastructure, propose to improvement measures for areas identified as deficient, and as well as action plans for the creation of new infrastructure. To support this, we provide a cartographic base to support the diagnosis, inventory, and proposed action. For the methodology, we did a methodological stage divided into phases. Phase 1, is office work where we did a spatial analysis and preliminary delimitation of the different areas, and phase 2 is field validation for the database. When we know about how many kind of infrastructure the village has and what is more important than the others, we decide to design a different indicator to take information about them, and we decide to did a municipality division for the different neighborhoods and urban areas. In this map, we can see the limit of the area studio is in the yellow color, and the other colorful areas is the different urban areas by neighborhoods. For the result, the study was inventoried by 354 urban green area infrastructures, only 20 very urban green infrastructure. So when we did all indicators and analyzed this, we take information about how many area per habitant has urban and peri-urban green infrastructure, what is the total area and percentage of green infrastructure area relative with the different division, the municipal division area, and one of the most important indicators in the inventory was division level strategy of classified as different color, green, amber, and red. Green say that all of the part of the infrastructure is okay. Amber needs to solve something, but it isn't important, and red is very important to solve the problem. Another result was traffic light indicator classification by different urban infrastructure typology. How many trees per 100 inhabitants, and what is this kind of spaces for the trees? To the end, we calculated a carbon absorption for the different spaces, for tree species. To improve the green infrastructure in the village, we propose a different proposal, like implementation of the action identified during the urban green inventory, use the different opportunities areas to create new green areas, creation of new ecological corridor to connect the different infrastructure, peri-urban and urban. And for end, we did a planning of new localization for urban tree line alignment. To do this, we proposed to 5-year development plan to do all of this proposal and estimated different cost for proposal. And at the end, we calculated the total budget for this one. To conclude my project, we found that the municipality has a signal quantitative provision of green infrastructure. The methodology developed is effective and replicable. The proposed action plan is ambitious but feasible, and the study goes beyond the local scale and constitutes a planning model transferable to other municipalities. And thank you for all of you.
Thank you, Manuel. You have already? The floor is yours. Thank you.
Good morning, everyone. My name is Jose Cipra. I'm going to present my master thesis. And this time, my presentation is titled Optimizing Fire Severity Mapping in Mediterranean Ecosystems, a comparative analysis of hyperspectral and multispectral vegetation indices. A little bit of context, we know that wildfires in recent decades have been weighed and damaged a lot of landscapes, and it's needed to assess this with the fire severity like using methods like remote sensing for assessing this type of indicators. And also to use these images to get some vegetation indices that can highlight the characteristic of these burn landscapes. And I like this image because it's kind of confused. At first glance, I thought that was kind of a volcano, but in the quote of this image was mentioned, it's like a volcano, but it's a burnt forest. So the objective of this research was to evaluate the performance of the vegetation indices derived from multispectral and hyperspectral data to estimate the fire severity across Sierra de la Culebra wildfire. The method used for this was to evaluate this area, only Sierra de la Culebra, because there's another area next to it, and it was located in Zamora, Castilla y León, and the first date was between 15th and 19th, 2022, and the affected area was around 28,000 hectares. The sampling method was random stratified, and the plots were of 30 by 30 meters square, a total of 70 plots. And the ecosystems evaluated were coniferous forests, broadleaf forests, and shrublands. As you can see in the map, we have the 3 ecosystems there, and also the plots in the yellow dots. And how can we assess the fire severity? Well, we have an index that is called Composite Burn Index, or CBI. And we split it in 3 types, like it's vegetation CBI, soil CBI, and site CBI. The thresholds to measure which is the highest or the more level of damage and the lowest one is the ones who are there is 1.25 below that threshold. We have a low severity. Between this and 2.25, moderate, and above it, the high severity. As I mentioned in the objective, we use 2 types of data, hyperspectral and multispectral data. For the hyperspectral, we got the information from the Prisma agency, the Italian one, and from Sentinel, the multispectral. And there are some characteristics that I showed here to see some particularities that we have in this type of data, like the wavelengths and the spatial resolution and the number of bands applied for this study. Also, it's important to mention that we use a bunch of formulas to calculate the vegetation indices, like the classical broad bands indices and the narrow bands. But if you see in this chart, you can notice that we use some of the classical formulas to calculate, to compute the hyperspectral vegetation indices. That's why, because we try to use the most of the knowledge and the information that we have to have the better prediction of the fire severity. The univariate linear regression model between the CBI and the vegetation index was used. We got the different correlations to know what is the best vegetation indices for each of these classifications. And after that, we use the mapping to extrapolate this information. Some of the results are shown here. And you can see in the left part, we got a bunch of vegetation indices and different values, that some of them got the highest correlations and some of them lowest. And the same happened with the multispectral data in the right side, but because we don't have many bands, so we didn't have many data to plot. Here we have some of the results that we got. This is for the hyperspectral images. And we can see that the vegetation CBI with shrublands and broadleaf was the ones who got the highest correlationships, and we use this for the next step. And here we have the multispectral, and we can see more or less the same trend as we present in the previous one. After plotting the vegetation indices in the maps and extrapolating the whole area, we got the proportion of the low, the moderate, and the high severity in Sierra de la Culebra area. And we can see some differences comparing, for example, the third and the fourth, because the third is related to hyperspectral soil and the fourth about the multispectral soil. We can see that the moderate level is different, or the high level is a little bit less than that was produced in the hyperspectral. So we can see some differences in this type of results. As a conclusion or the takeaways messages, we can say that the hyperspectral indices provide superior estimates for the fire severity in Sierra de la Culebra, where the CVI at the vegetation level got the stronger correlationships. And also the broadleaf forests with the shrublands had the best correlation with the CVI, where the cellulose absorption index and the normalized vegetation red age index were the ones who got the best correlation in this study. And you can have here the paper published recently of part that was about this study. And thank you so much for your attention.
Thank you, Jose. Maybe until Eric will be ready, I can open the door for discussion if you have questions for the presentation. If you have questions, you are welcome.
Yeah, it's okay.
Okay, so I will give Eric only 6 minutes. Please.
Yeah, good morning. Thank you. So I recently defended my thesis, and because I've been presenting the topic over and over, I decided to bring a topic that is a bit broad, looking at the conference, the context of the conference. So in case you are confused and you want more information, I'll put the QR code just for you to read more about it. So the title is Why Early Competition Matters for Climate Resilient Mixed Forests. I think today there's been a lot of talk about mixed forests and monospecific forests. And the idea I want to share here is the fact that we can see the monospecific forest is talking about forest structure where the species have the same structure and more or less the same age and the same height. But the mixed forests, as we can see on the other side, have kind of like differences. But lately, there's been a shift from the monospecific forest to the mixed forest. And why so? So one of the main reasons is because due to climate change, the mixed forest tends to show a higher resilience as compared to the monospecific forest. So I'll show examples of what we can see when it comes to the mixed forest and the pure forest. So here we can see on the top part, so because of climate change, the first example we want to see is a drought. So we are comparing the drought, the condition of the monospecific forest with the mixed forest. So we can see here during drought, just because of the fact that the monospecific forests are the same trees, when they have to take water, they take it more or less from the same level of earth or the root system. Therefore, when there is drought, it's easy for it to be impacted negatively as compared to the mixed forest. Another example is the high heat stress. So when a monospecific forest faces a high heat stress, the observance is different from the mixed forest. And another example is when it's affected by pests and diseases. the mixed forests tend to show positive impact as compared to the monospecific forest. And also the infestation is the same. And lastly, the rainstorm. I think yesterday Hans talked about the rainstorm. So the mixed forests tend to show positive effects as compared to the monospecific forest. That means that mixed forest is quite important, but there are less information about the young mixed forest as well, because more research is done on the matured mixed forest, but the young mixed forests are also equally very important. Why? Because they actually determine the future of the forest. So this study actually looks at what we have to do when the mixed forest is actually in the younger stage, so that in future we can have a long-term future, which is also mixed forest. So the question we pose here, or we ask here, is how does the early competition affect the tree structure and also the tree growth? So we're going to compare the two species that we study, and then also check whether the competition affected directly or indirectly. The study was done in, of course, Spain, Burgos, Quintana de la Sierra, and as I said, it's focused on the young mixed stands. So these stands are very young. The reason why they are young, we focus on the young, is because a lot of research is being done on the matured mixed stands. Okay, so the method we used was actually destructive method, where we completely cut down the tree. So this was not a semi-destructive or an indirect estimation. It was a complete destruction of the trees. And the total number of trees we used was 90 trees. We measured the DBH, the height, the crown length, and also we determined the competition among the species or among the stands. And we used the basal area of the larger trees. The first outcome we had was the fact that competition actually affected all the relationships we took into account. I will not go so much into detail because I'll share the paper, so in case you want to have more information. Thank you. So in this study, we studied only the Scotch pine and the Pyrenean oak. So therefore, we also have to check what is the behavior of the two species, what is happening to it under competition. So under competition, they tend to show different behavior when they are under competition, or different strategies. The third one is the fact that we also have to check whether there is an indirect effect of competition on the biomass allocation. And clearly, competition increases the tree height. Greater height leads to more stem and branch biomass, and foliage biomass is largely unaffected. So why these results matter? The fact that this result is very important because the early competition determines actually the growth and the development of the tree. So competition at the early stage is very important because it determines the long-term development of the forest. And also the species, one thing about the competition at the younger age is because the picture I showed previously, if you have 3 different species in the same stand, if you don't control the competition at the younger age, you realize that at the matured age, you only have 2 species, or maybe 1, because the others have killed the other species or have dominated. Therefore, it is important to control competition at the younger age. And also, early decisions have lasting consequences. So whatever we do at a younger age, for instance, when we think at the younger age, it has consequences in the long term. Its implication generally means that when there is an action or forest management to do at a younger age that is cost effective, we don't wait till the future to be able to pay more to do forest management. So it's better to do the management at a younger age because it's going to cost less. And also, there are factors that you can control at the early stage rather than waiting when the tree is 40 years or 30 years. The take-home message is that early competition matters more than we think. Species respond with contrasting growth strategies, and managing early stages is key to climate resilience. Thank you for your attention, and I also want to thank the people who helped me to be able to do this work and my supervisors as well. In case you want to read more about the paper, that's a QR code. Thank you so much.
Thank you, Eric. So before leaving for coffee, if you have one or two burning question only. Okay, please.
Good morning. I have a question to Lucia. So I really enjoyed your presentation. I think you have a lot of work. Your methods are really well explained, and your results looks like really promising. But my question, more than a question, is like a big comment. The question should be, because I'm really curious about at the end how will you apply the product, right? Because and the comment is because I think that your research, your objective is really ambitious. So you want to control 2 vascular pathogens, and you can say, okay, they are vascular pathogens, they are similar, but it's not. They are not really similar. One is a bacteria, the other is a fungi. Verticillium infected the roots. Xylella can infect the aerial part. Verticillium goes in the xylem, but Xylella goes in the phloem. So they are really different. And what you want to apply is, I guess, a microbiome to a combination of beneficial microorganisms that can control those pathogens. But that means that you can have the same microbiome in the roots and the aerial part. So for me, it's not really easy to understand that. And also, that treatment should be curative or preventive, because I don't think you can use curative right now, because if Xylella is detected, I think you need to remove your trees. I think that's the law right now, right? And preventive, you also have the risk about you disrupt the actual microbiome, which is beneficial, I think, because those trees are really old. So I don't know, how do you plan to apply those? So I think the approach is really good, but I cannot imagine what is the best application. Thank you.
Thank you very much for your open, for analyzing everything. So as you said, it is kind of ambitious because the management of the 2 diseases right now it's different. And as you said, the legislation right now says that when you find one Xylella positive tree, you have to create a buffer zone around it for all the host plants, which are over 100, so it's kind of probable that you have to leave a really big blank space around it. So as far as I know, I think Xylella it only goes in the xylem, not the phloem. So that's something in common with Verticillium, because you are right that Verticillium enters through the roots, but we have found it in the in the aerial part also, because it kind of blocks the xylem. So our hypothesis is that the consortia, the SYNCOM, will gain the competition between over the pathogen, maybe because of the space or of nutrient competition, one of those. And I forgot the last comment you said. Sorry.
No, about do you think it should be preventive?
Oh,
or
okay.
curative?
So in the national project that we are working right now, we have both scopes, preventive and curative. In curative, we are actually going to try them on Italy's field, which is kind of infested with Xylella in the south part. So we don't have results right now, but as you said, the application will be different because they are like really old olive trees, and we applied the products by endotherapy. So when you have nursery trials, it's easier because you just inject it in the xylem, but in the field, we are actually collaborating with a company for endotherapy, but we will see. So it's
Okay.
promising, but it's difficult.
It's a lot of
Thank-
work and a lot of parameters that you need to control, but
Yeah,
good luck.
Exactly. Thank you.
Thank you.
Thank you, both. Thank you, Lucium. Only but one question.
I do have a question for every one of them, but I will not give all my questions because it's lacking of time. My first question goes to Aman Ali. I just want to see, because you use the Landsat data and the consumer force to be able to, I would say, to estimate the development dynamic of forest power. I just want to know if you have been able to use the GFW, Global Forest Work Database that have been developed by Harvard. I know that it starts from 2020. It doesn't cover all of it, but I just want to have you been aware of this database to compare the result with this database?
Not really. So the idea was to make the time frame equivalent with the Spanish National Forest Inventory. So that's why we chose the Landsat. So
Yeah, this database also is based on Landsat images.
okay.
Yes, they are Landsat images. That just to give you an, I would say, instant price to be able to use it if you want. Ortiz, you, Mr. Ortiz, identifying the most suitable forest species, used mainly Maxent as how to say model for predicting, and we know that Maxent is based mainly on presence and absence and the probability of the occurrence of some species in somewhere. I wonder if you have been thinking about using some mechanistical models.
Hello. No, we only use Maxent and we don't prove any more algorithm.
Because there are some also mechanistic models that are reliable. You can just load them, download them, and try to see what is the difference between your models and those. And my last question is for Taira, Annabelle. I really like your presentations. Small question. How did you map all the trees? Is there any database that is already available, or you had to take your GPS and go?
Hi, thank you for the compliment and also the question. The data already exists in the government, like it's open access data by the Rotterdam government, but it is provided by civilians. It's like a civilian database where there's a lot of ecologists that are very passionate, and they will mark these trees themselves on a GPS and with pictures, and then that gets collected to a government database.
Yeah. And your suggestion, you suggest that they should have mixed trees within. Have you been able to identify what is the most suitable mixture of species?
Unfortunately, I think this would require field studies in an urban context, because all of the literature that I consulted was, funnily enough, also a lot from Hans. It was his papers that were referenced. And these are obviously in forest plantations. So I think an in-field study in an urban context would be necessary to determine the optimum species composition. Thank you.
Okay, thank you. Any more?
I have a question for Kiana. Also, I congratulate the presentation and the work behind the presentation. And I would like to know if you distinguish between aligned trees along the streets with patches of urban forests inside the city. You analyze or you have information from the literature review about difference in the arrangement patterns of the plantation?
No, but that would be very, I think, useful for future research. I think ideally, again, the literature that I consulted was mainly forest stands, assessing the dynamics like of interactions in those contexts. There is very little research done in this urban context, so I think this just needs to be done in the field. Thank you.
Okay, thank you. I also have some questions, and the first question for Jose. How reliable is the multispectral detection of forest severity?
No? Well, I use, thank you first for your question, and we use two types of data, one multispectral and the other hyperspectral. They are reliable in terms of you can correlate with the ground data. So the difference between both of them is that the one have more detailed and continuous information about the field, which is the hyperspectral, because then they have narrow bands. In the other hand, the multispectral have a broad band, but is also reliable in terms of have more information because it's more available than the hyperspectral that is on demand.
Okay, thank you. And for Sophia, what is the effect of silvopasture or including animals in the forest management and the challenges?
One of the main challenges is actually access, because our cities or our streets are not built to accommodate a large trailer full of livestock. So often one of the major challenges was how we get the animals to those properties in general. Payment is also a large prohibitive factor. That's why we have this grant program. So often when wildfires come through, the resprouting of vegetation is really expensive to manage, and landowners have just dealt with losing their homes, so they don't have the funding to manage this on their own. So that's why this program exists, is to reduce those ladder fuels and actually provide access to funding to do this work. So it has varied ecological benefits as well as public safety benefits. But the main one is reducing those ladder fuels, because we've had a wildfire event in my county pretty much every year since 2017. So people are continuing to lose their homes because of this high accumulation of fuel.
Okay, thank you. And for Manuel and green infrastructure, green urban infrastructure, what needs to be considered by urban municipalities and from your experience?
It's very interesting to do this kind of project, because you can see what is the implication of the city with the environment, and what kind of green areas has the different cities or places.
Okay, thanks so much. So we'll continue our discussion if you have any questions during the coffee break. So thank you. A big applause for all our speakers. Thank you. Thank you.
Remember that you can vote for your poster selection in the box, okay? Also, for the next section, I need the speakers give their presentation to the next chairperson. See you at 11:30.
Okay, I think we are all together here. Welcome to the last session of the Young Foresters meeting. I hope you are enjoying this congress. Good luck to the next speakers. The next and first speaker from this session is going to be Franklin Riera. Welcome to the stage.
Thank you. Hello everyone, my name is Franklin. Today I'm going to talk about my project, PointNet-based individual tree species classification from high-density mobile and public LiDAR data. Don't be scared for this long title. This work explores how a deep learning model can perform a lightweight binary classification of tree species using of 3D geometric information from LiDAR point clouds. Okay, I will introduce my project through three key questions: why, how, and where. Let's begin. The first question is why to classify tree species. Tree species information is essential for the forest inventories, biomass and carbon estimation, and sustainable forest management. The next question is why to do a binary classification. On the one hand, this work explores how a deep learning model can effectively classify between two species using only 3D geometric data. On the other hand, Pinus sylvestris and Quercus pyrenaica are the important and significant tree species in the Iberian Peninsula, and they frequently coexist in the mixed species forest. Furthermore, broadleaf species such as Quercus pyrenaica exhibit highly variable and irregular crown structures, which suppose a significant challenge to the generalization capacity of AI models training on 3D point clouds. However, there is a notable lack of systematic evaluation of point-based neural networks across the contrasting their morphologies, such as coniferous versus broadleaves. Finally, while LiDAR has become a standard tool in the forest remote sensing, most species classification approaches still rely on spectral data or handcraft features. The potential of purely geometric deep learning using only 3D shapes remain underexplored. Our objectives. The first one, evaluate the performance of algorithm 3D species developed by Professor Lucas Winnie Werther. Test the binary classification, Quercus and Pinus, input only X, Y, and Z coordinates, and assess the convergence behavior classification, stability, and geometric discriminative power. Where is located the area of study? The picture shows the study area, the site A and site B. The site A is Villaverde del Monte and site B is Tera. Both are located in the province of Soria. How is composed my data sets? The first data set, Quercus pyrenaica, were collected using a HeosLAM, a mobile LiDAR sensor. 9 forest plots were scanned in the sites that I said before. Individual tree segmentation was performed manually using Cloud Compare. The database for Pinus sylvestri is a public database for species 20K project by Polity. It has around 20,000 individual tree-point clouds by 33 species. We only use a random subset of 80 from 3,000 individual of Pinus sylvestris that we're scanning using the mobile LiDAR scanner. This workflow shows how the main dataset was structured. They combine the two databases, the Quercus and the Pinus, and you can see the both samples of the point clouds. The main dataset has key variables, for example, tree ID, species, database, X, Y, and Z, height, number of points, file name, chain veil, that is important for the training, and class, 0 for Quercus and 1 for Pinus. The next image illustrates some samples of individual trees from the main dataset. The main dataset consists of 160 individual trees, 80 for Quercus pyrenaica and 80 for Pinus sylvestris. This balanced design avoids the class imbalancing during the training. Okay, here you have some photos of the field where we survived in Soria. The 3D species algorithm based on the point net architecture is specifically designed for geometric point clouds classification. The dataset were split into 70 training and 30 for validation, with the split applied independently for species to preserve the balance. The abstraction level was set with a number of points equal to 16,000, and additional data augmentation with a z-axis rotation with 6 rotations, each 60 degrees. For instance, 0, 60 degrees, 120 degrees, and to 300 degrees. Finally, the multi-layer perceptron was trained for 20 epochs on a binary classification where class 0 represents Quercus and class 1 the Pinus. We intentionally adopted the lightweight classification to evaluate the performance to classify these two species. Test preliminary results shows that the model converges rapidly and achieves near-perfect performance. This suggests that the LiDAR derived 3D point geometric contains highly discriminative information for classifying two species. You have here some values about the results of the first train, how I said before, some settings, and the preliminary results shows overall accuracy on 91% of the 17 to 20 epochs. Additionally, the training and validation losses low and stable and no evident overfitting in this task. Additionally, we have this image to show the preliminary results, how we have 22 correct classified in the Quercus and the Pinus, and 2 errors in the both class. 3D geometrics alone could be as sufficient for species discrimination. The model effectively captures a structural difference, but although these results are promising, it's important to note that it's a relatively simple binary classification task, and these results are preliminary. Performance may vary significantly in more challenging scenarios, for example, when classified between closely related species like Quercus faginea or Quercus pyrenaica. But in the summary, this first experiment demonstrates the potential of lightweight point net models for the 3 species classification using only LiDAR point clouds. The next challenge consists in validating the robustness and transferability of this approach in more complex and heterogeneous forest inventories. Okay, if you would like to learn more about this project, please scan this QR code. Thank you for all your kind attention.
Thanks, Franklin, for your presentation. The next speaker is Girma. So, welcome to the stage.
Okay, thank you very much. Good morning, everybody. My name is Girma Nuguse. I am a PhD student from the University of Gondar, Ethiopia. And I am here by the opportunity given by the Erasmus and UVA. So in this occasion, I want to thank to the Erasmus and UVA. And also I am really happy to present my work on this respected conference. So my work is entitled with knowledge of wild edible plants across social groups in northern Ethiopia. So as the introduction, as you know, wild edible plants are very important as for economically, ecologically, and as in terms of food security. However, these wild fruits are important, but in the study area, the diversity of the species and the knowledge of perception on this wild fruit is not studied in this selected district area. So the aim is to document wild fruit diversity and analyze how ethnobotanical knowledge varies among social groups. So the study was conducted in the Abergele district, which is northern part of Ethiopia, and the area is dry land or drought-prone area. So how we conduct is we collect the data from 387 key informants with semi-structured interviews, focus group discussion, and guided field work to analyze the habitats and the species types of species. And the analysis was done by documentation and statistical. We used the statistical instruments like ANOVA, correlation, multivariate, Paranova, and NMADs are to explore the knowledge patterns. So we have the 5 key findings. The first finding was the area is rich with different types of plant species. We document 40 wild edible plants within 22 families, and the growth forms was almost the majority was tree and shrubs, and primary use of the wild edible plants were 70% of the species was considered as fresh or raw, and the habitat or the distribution of these wild fruits is we can find in natural forests, grazing land, river banks, and farm edges. So as example, these species are, this is this first, and this is Diosporus, and this is the Syzygium, and this is the Zymenia. The key finding too was knowledge is not evenly distributed among the studied area. As you can see the figure, the key informant has almost 2x of the general informant, and also gender, occupation, family size, and age is a factor of the knowledge, because male has high knowledge than the female. This is because of the interaction with the rural areas. The male has more interaction with the wild fruits, so because of that, the male has know more than the female. So with the status, age, family size also affects the knowledge of the wild plants. The other key finding was multivariate analysis of knowledge pattern. As you can see the figure, there is clear difference cluster of between key and general informants. The general informant was scattered, very scattered, which means they know the less number of wild edible plants, and also general informant one knows the knowledge of general informant one is different from the other general informant, not in the number but also the type of species. But here the key informant is almost the same, and they know more knowledge of, they have more knowledge of the wild edible plants, and they also the same knowledge of the wild edible plants. They know more and they know the same types of species. And the other finding was seasonal availability. This wild fruit was more, we can find the matured wild fruit from June to October. So the red line is the occurrence of wild edible plants. The blue color was represents the preference of the local community to collect, because these 3 months are critical for the local community So the other findings was the threat. These are the major threats of these wild river protests: deforestation, agriculture expansion, settlement expansion, overgrazing, etc. are the major threats of the local. So when we come to the conclusion, summary of the key insights were wild river plants are indispensable for food security and cultural resilience. Ethnobotanical knowledge is rich but unevenly distributed. Wild edible plants serve as seasonal safety net and have multi-livelihoods. These species face several anthropogenic factors. So I want to acknowledge these individuals because this individual has a great role in my PhD journey. Professor Pablo, Dr. Gonfa, Dr. Asmamo, Dr. Daniel, Dr. Hermes, and also my mentor, Marina, and my colleague, Dr. George, Dr. Eric their role was very critical for my PhD. So I would like to thank you for your attention also. Thank you.
Thank you, Girma. Okay, the next speaker is Samran. There you go.
Hello everyone, my name is Samran Shokat. I am a student of Medfar at University of Padua, Italy. Today I am here to present a project Impact of Climate Change on Forests and Natural Resources in Pakistan. Pakistan is an agricultural country. As per the Worldwide Climate Index, Pakistan ranks on 8th most affected country in the world. Climate change is due to many factors, but I am here today, my main focus of the lack of forests. Pakistan is a country with one of the lowest forest cover in the world. We have only 4.2 million hectares of total land, which is very less. The main impacts of climate change on Pakistan, we can see the map of Pakistan. The red area is mostly heated due to climate change. We can see that mostly 70% is 70% area is heated temperature between 42 to 45. In recent last year, we also noted 48 centigrade in area of Pakistan, Dera Ismail Khan. And this increasing of temperature, we also facing the deforestation and the different types of diseases in our forests. The increasing of temperature also affects melting of the glacier, which glacier turns into horrible flooding across Pakistan. We almost facing floods after every 4 to 5 years. Droughts. Due to floods, when floods gone, we are facing a lot of land in the form of droughts. Impact on agriculture. Pakistan is an agricultural country, mostly around about to 64% population depends on the agriculture activities. But climate change is affecting yearly our agriculture, like decreasing in crop yield, loss of soil fertility, and these are main causing of food security is becoming a challenge. We also have a problem of fresh water because climate change is causing for the flooding. So flooding also affecting the fresh water. What we are doing to control this climate change? We have some major projects like 10 billion trees tsunami government of Pakistan started at 2018. We can see in first picture before and after. We have an aim to 10 billion trees, and when we start, and we can see the difference before and after. Mangrove restoration in Indus Delta. Indus River is located in Pakistan, province of Sindh. We are also growing trees and forests beside of this river. And in first picture, we can see a man growing trees, and the second picture, you can see the results. So these are the references from where I get the data, and thanks to all of you.
Thanks for your presentation. The next speaker is Encarnación. So welcome to the stage.
Hello, thanks very much. It's a pleasure to start here today. My work focuses on plant community assemblage, especially in the process that during a secondary session. As we already know, the global change is characterized by increments temperature, change in the precipitation, and increments in disturbance such as Wi-Fi. Many research have studied of assembly plant community assemblage, such as Clements or Glaxon, but now many models agree that plant community assemblage is a dynamic process that develops over time. This process is driven by combined action for abiotic filters, abiotic interactions, and stochastic process. Therefore, the plant's biodiversity is the result of the combined effect for these factors. The Mediterranean ecosystems show a strong seasonality where the worst period coincides with the driest ones, creating a high stress for the plants. In addition, these ecosystems are affected by recurrent disturbance, especially wildfires, whose frequency and intensity are increasing due to the global change. Disturbance reduce cover and restart successions, because for this, the time between events shapes the community. Here, the functional traits are acute, has climate and soil acts filters that decide which species can survive. With all this information in the mind, our study address follow these center questions, and our hypothesis suggests that abiotic filters are dominate right after of the disturbance. However, over the time, these filters weaken and abiotic interaction become more important. We study 7 sites in south of Salamanca from 400 and 1300 meter height. To analyze temporally dynamics, we use a chronolyze. At each site, we picked 3 plots: young, intermediate, and advanced stage. In this plot, we measure the species cover. We also compile more information for 11 functional traits. We use a climatic atlas for weather data and chemical soil analysis for the growth. Finally, the succession age definitely as the time since the last disturbance was determined through chronological analysis for the long life individual. We did all studies in air. The first we characterized by abiotic filters using two PCAs to summary climatic and soil data. Then we use NMDS to describe community composition based on Bray-Curtis distance. We also use a SEM to find a relationship between abiotic factor, age, and biodiversity. Finally, we calculate biodiversity using indices for species research, functional trait, and phylogenetic structure. As in this picture, the climatic PCAs, the first axis, CLIM1, goes from wet and cool sites to dry and warm ones. The second axis shows a diarrhea temporality change. For the soil PCAs, show a gradient for less arid soils to more acid ones. In here, you can see the two graphs in NMDS. The species show a clear gradient. On the positive end, you see a species adaptive for hot and dry condition, and the opposite, you find species from colder and wet environment. In the second graph, the trials see a different ecology statistics during succession. All our SEMs follow a same structure. Abiotic filter, climate and soil, and age determine the trait composition, which then affect biodiversity. In this diagram, we see that the trait 2 is a key predictor for the species composition. This trait dimension is strongly influenced by CLIM1 and age. The three dimensions of the biodiversity are strongly like for trait 2, which is driven by climate and age. The functional diversity, the axis, the trait 1 also play a small logical role. Regarding the phylogenetic, MNTDX is related to climate and age through these traits. However, the PD axis show not such like. The means is not directly influenced by the abiotic filters or age. Climate and age drives a community assemblage. There is a shape functional trait, both taxonomic, functional, and phylogenetic diversity. However, new species are closely related to existing ones. This shows that even as research matters, strong abiotic filters increase over the time, over which strong abiotic filters as a new species belong to similar lineage. However, the age drives habitat heterogeneity and both all the three dimensions of diversity. However, more frequency fires trait is processed by a short the time needs to recovering. This limits the complexity for the ecosystems under strict climatic control. Thanks for your attention.
Thank you, Nuski, for the presentation. The next speaker is already here, Mohamed. There you go.
Hello everyone, my name is Mohammed, and I'm also Medford student studying in ISA for my first year. Today, before I start my presentation, this is you can say a review article done by research is being done by someone else. So the topic name is Forest Fire in Portugal. And the research question is it possible to predict burnt area using available data to optimize resources allocation? So we will try to answer this question. So in this picture you can see we have three areas. The first one is bush area. You can see the hotspots of fire being erupted by bush. The second one is area denoted as populated area, and you can see fire being by reddish area. And the third one is agricultural area, and you can see again there are few hotspots of fire being done by agriculture wastage or the burning of agriculture land. In this slide we can see that we measure carbon dioxide being emitted by these burnings, and you can see that in Visu, the extreme left column, you can see that 1474 ton carbon dioxide emissions calculated. And this is a total estimated carbon dioxide emission from the forest fire that is close to 13 million. So the question is that are natural fires are relevant? So in general or prospective, no, they are not. Because when we see this graph, you can see natural fires, originating, unknown, intentional fires, and negligence fires. So we statically this data is being presented, and the natural fires are at lowest. So how we have data to predict the burnt area? We use multiple systems like the GPS data being done with various satellites and geographical data, and the second one is fire weather index system data, and third one is time stamps. Time stamps like when we have fires in a particular area, we assume that like the fire is erupted in Visu from mid-July to mid-August. So we calculated these timestamps to follow steps before the fire. In this slide you can see there are two models. The first one in green is a model result that we use statistical data with from the last slide, GPS data, fire weather index system, and timestamp. So we we predicted burn area before the real fire erupted. So in this green line you can see that the total burned area predicted was 9,640, and the actual burned area in real sense was 10,106. So the accuracy of data is about 95%, and these are being done in since 2013. So in this regional pattern of fires, again you can see three maps, and the first one is total fire, and the second one is fire done by negligence, or the third one is the fire done by intentional fire. In this I can define that there are three types of fire. The first one is natural fire, and the second one is negligent fire. The negligent fires can be defined as those fires that are you can say somehow being driven by human factor, like the burning of agricultural land, the burning of wetlands, and the third ones are the intentional fires. These can be defined as like agriculture machinery, or you can say industrial fires. So these are the three data. And in this slide you can see I just quoted 4 projects, but there are multiple projects. The first one is FireRIS, that is being operated in my university, ESA campus, And the second one, fire EU risk, is being done by EU. The third one is resist, and the fourth one is life landscape fire project. So these are the references from the data is driven, and thank you very much.
Thank you. The next speaker is Anna.
Well, hello everybody. I'm Ana de Torre, and I'm going to share some of the results of my PhD. Today I'm going to talk about how shrub patches influence plant species composition and biological structure in post-mining pastures. Facilitation process in ecology refers to positive non-trophic interactions between organisms in which one of them benefits and none is damaged. And this process has been observed in some shrubs that can improve microclimatic condition and also edaphic properties, and they can also offer protection against herbivores. And this way, shrubs can help herbaceous plants and also tree seedlings to establish themselves. And this facilitation process is really important in degraded lands, such as those resulting from open pit coal mining activity that was a common practice in the north of Spain in the last decades. And in many cases, these degraded lands has been rehabilitated to pastures with grazing use, as you can see in the right-hand photo. And in these pastures, it has been observed that some shrubs such as Genista florida or Cytisus scoparius has colonized them. And these shrubs here can play an important role in the facilitation processes. And these lands have an important lack of soil structure. So the main objective of our work is to assess shrub patches' influence on the herbaceous layer in these post-mining pastures, and also to quantify their effects on the biological structure of the plant community in terms of plant families, lifespan, and rank-wire life forms. The study was carried out in the north of Spain, specifically in the north of Palencia, near Guardo. This area is characterized by a Mediterranean subhumid climate with a summer drought that causes water stress for plants. And the pasture is surrounded by a Quercus petraea forest that once occupied this area before the coal extraction. Here you see the experimental design. This is the mine called El Sestil that was rehabilitated to pasture in the 90s. And the red dots are the 5 sites we sampled. And on each side we sampled a shrubby patch and a non-shrubby patch. This is an example of an shrubby patch that is dominated by a Genista florida, a large individual of Genista florida, surrounded by other smaller shrubs, such as itself or Cytisus scoparius, and to a lesser extent, Rosa canina, Rubus ulmifolius, or Crataegus monogyna. And this is an example of a non-shrubby patch in the open pasture that was at least 8 meters away from the shrubs that you can see at the back of the photo. So what we did in spring 2024 was collecting samples under Genista florida patches and also in the open pasture. And following the orientation, we used 20 centimeter side quadrants to visually measure the percentage cover of each vascular plant species, moss, and total vascular plant. And with an hydrosense device, we also measure the soil moisture. And with each vascular plant species, we grouped it by plant families and also by rank-wire life form, as you can see in the illustration, and by lifespan, to use them as variables. And with the vegan package in our studio, we perform a detrended correspond analysis of these species cover inventories, and we perform MV function to fit the variables over the ordination, and with the ordi-ellipse function, we project the variables that were significant. So here now you can see the result. This is the DCA of the 80 species cover inventories. And now in colors, you can see the inventories located in the open pasture in green versus the ones located under Genista florida patches in yellow, and the standard deviation ellipses groups inventories with similar species composition in this graphic based on the position. That was a significant factor, and we also found significance in the site and in the interaction between position and site, and in the interaction between position and orientation. Therefore, there are clear differences in species composition in the inventories located in the open pasture and in the ones that was under Genista florida patches. And we also find differences among the inventories that are located under Genista florida patches, and this can be inferred from the larger size of the leaves. As you can see, the larger size of the leaves in the shrubby patches than the one that is in the open pasture, that is smaller, meaning that there is more homogeneity. Now we are projecting in blue arrows significant variables related to family plants, and we see that the families that predominate in the shrubby patches are Poaceae, Violaceae, and Rubiaceae, and the ones that predominate in the open pasture are Fabaceae and Plantaginaceae family. And Asteraceae seem to occur in both positions. We are now projecting other variables. We see that moss cover and soil moisture is higher in the shrubby patches, and the vascular plant cover is higher in the open pasture, probably because there is fewer space occupied by the mosses. And finally, we are projecting variables related to ranquire life form and lifespan. We find in the shrubby patches perennial herbs that are hemicryptophytes, and also woody plants that are phanerophytes, like the regenerated of Genista, Ocytisus, or Rubus, and also camephytes that were mainly Arenaria montana and Stellaria lostea. And on the other hand, in the open pasture, we find short lifespan herbs that are pterophytes, probably because they can tolerate better water stress since they pass through the summer in a sheet form. And finally, as a conclusion, there is an effect of the shrub patches on plant species composition that is mediated by the site and the orientation, and specifically these Genista florida patches promote Poaceae, Violaceae, and Rubiaceae family cover, soil humidity, and mosses. These communities are dominated by perennial herbs and woody species, and in the open pasture, Plantaginaceae and Fabaceae are more abundant. There is greater vascular plant cover that is dominated by herbs with short lifespan. This way, shrub patches shape plant community structure in this post-mining pasture, and so they can have an important role in restoration and management strategies for these degraded ecosystems. And well, I want to thank every member of the Restore Mine project, and thank you for listening.
Thank you, Anna, for such interesting presentation. Our next speaker is Natalia Crespo. Welcome to the stage.
Hello, I'm Natalia, and I'm a PhD student in the University of Valladolid, and I'm going to talk about part of my work that is, in this case, long-term evolution of pine and oak forests across the municipalities of the Bosque Modelo Palencia. We see that there is an information gap between the forest information that we have at the national level to the local level. So we have modern forest management demands informed decision making at local level, but the information is disaggregated in different databases and disconnected, and also they have different formats. So it's difficult to use this information and different levels that they are made to do it for making decisions on this local level. So we have, for example, at the national level that the government publishes this information for free. National Forest Inventory, different edition of this, national forest maps, and also administrative boundaries So we use all this information to analyze the forest in the Bosque Modelo Palencia as a case study. Since this area is candidate to become the first model forest in Spain, because promotes local participation in forest management and conservation, and it covers 91 municipalities with a total of 4,000 square kilometers. And of this area, 28% is forest area, and of this 28%, 24% is pine and oak forest. And most of these pine and oak forests are public forests. And the area of pine is 44,000 hectares, and for the oak forest is 33, almost 34,000 hectares. So the main objective of our work is to integrate all this information, just from the inventory, the forest maps, and also for the municipal boundaries, into decision support systems using link open data, geographical information systems, and also interactive dashboards, to see all this information in one glance, and facilitate the use of this to local management. So we have the first problem here is we have the last three forest inventories editions have information at the tree level, like height, diameter, basal area, and also at the plot level, aggregated this information per hectare, with volume, basal area, density per trees, per species, and also by stratum per province. In this case, Palencia has 14 stratum classes that are classified based on the main species, and also the cover of these species in the strata. But we don't have data in between the plot data and the stratum, like the municipality. And we can do this aggregation of just focusing on the plots information of the National Forest Inventory, because we don't have, in many cases, in the municipalities, a lot of plots to do with this. So we use more information, like the forest maps, to use the strata of the province to analyze and calculate the trees per hectare, the basal area per hectare, and the volume per hectare, to do a stratified overage. And using the different edition of the inventory that we have, almost 30 years of evolution of the trees, to see this stock information at the municipality level over the years. So we integrate all this information with other databases that are public in a dashboard, which provides a strategic perspective for territorial planning and summarize different information. We have this an example of a municipality of Velilla del Río Carrión in this Bosque Modelo Palencia that we designed divided in different areas, like municipality contest, when you have the location of the municipality, the countries, and also the quality and damage of the trees and the ecosystem services that we have in this municipality. This is the same example of the Velilla del Río Carrión dashboard, and we have the different parts bigger. So in the first part, we see the location, the county is Guardo, and it has 35 public forests larger than 100 hectares. And also more of the half of the municipality is within the Montaña Palentina Natural Park. So we can see all of this in this part. In the other parts of forest stocks, we can see the evolution of the trees per hectare, also the basal area per hectare, and the volume of the three main species, that in this case are Pinus sylvestris, Quercus petraea, and Quercus pyrenaica. And we can see that during the 3 inventories, the species are progressive increase in the both variables that we measure, and also that the mean species is Pinus sylvestris with a lot of difference of the other two. And also we can calculate the carbon storage, and we can see that the evolution of the carbon storage during this inventory is increasing in the third one and in the fourth one. We also have the information of the tree quality of the 3 inventories and the tree damage, and we can see that the tree quality increased during the inventories. Then in the second inventory, the tree quality, it was very poor of the trees. Almost half of the trees are standing dead or have diseased trees. And the tree damage is the decrease in the third inventory, but increase a little bit in the fourth one. And most of the damage are because of biotic factors and wind. And also we have another part, the forest characteristics, when we can see the number of plots in the inventory of each edition that they measure in the municipality, and the number of plots and trees that are in the same edition in the 3 editions of the inventory, and we can compare it. And we can see also the evolution of the surface of each species in the municipality. And we can see decrease in Pinus sylvestris and Quercus pyrenaica from one map to another. And also we can see this, the ecosystem services and evaluation of the estimate value of all of this. And conclusion, the integration of multiple databases has transferred and scattered information into useful knowledge for local forest management. Dashboards enable clear visualization in one page, allowing navigation across temporal scales like the inventories and forest maps. All data and graphs of this work are published in GitHub. And future work, we want to expand this dashboard to a national level, not just in the Bosque Modelo Palencia, through a web application like Forest Explorer, and increase data integration with other data like climate and other databases that are published, and conduct user testing with stakeholders to see the necessity of these people to use it to the municipalities or other spatial level, to know how they want to use this information and if we want to improve it. Thank you.
Thank you, Natalia, for your presentation. And now we are going to welcome Tamiru, that is the last speaker of the session.
Okay, thank you very much. I'm Tamiru, and I'm going to close the session for sure. And I'm going to speak on leveraging planet imagery and the LiDAR data to reveal the interactive driver of wild edible mushroom yields in Mediterranean forests. So this mushroom production have different ecological, social, and economic importance. The products have also contributed almost all of the Sustainable Development Goals, which is very important also to provide different ecosystem services, including the provisioning services, regulating services, as well as cultural and supporting services. So even though it has many important, but there are different ecological factors that are affecting the mushroom yield production, including the fire, the forest vertical or horizontal structures, the forest stand characteristics, stand management, topography, as well as climate change, especially in Mediterranean region where the high climatic variability is existing. So these all multiple and interactive ecological factors have a strong influences on the mushroom yield production. So integrating high spatio-temporal resolution remote sensing technology is very important to capture the intra-annual mushroom responses to these ecological factors. However, there is a lack of using this high spatio-temporal resolution remote sensing to monitor intra-annual mushroom yield responses along these ecosystems. So the general objective of this work was to model wide edible mushroom yields using the optical and the LiDAR data along the in situ data. And specifically, we need to identify the most relevant variables, as well as to assess the value of integrating the intra-annual vegetation dynamics that derived from high spatio-temporal resolution planet imagery and the LiDAR data. So the study was conducted in province of Soria, central Spain, under the Pinus pinaster and the Pinus sylvestri forest standards. And the elevation of this study area is ranged between 1,000 and 1,200 meters above sea levels. And the total annual precipitation in this area is about 500 millimeters. When I come to sampling, the sample plot was laid or established in 1995 in case of Pinus sylvestris and 1997 in case of Pinus pinasters. Of course, we used only 7 years time series data to align our data set with the planet lifespan. And 18 plots and for Pinus sylvestris and 20 plots for Pinus pinaster were randomly distributed across the forests. And the area of the plot is about 150 square meters. Each plots were also fenced in order to protect them from different illegal harvesting. So the data set that we used in this study is the mushroom yield. Actually, it's a biomass that was collected weekly for a long period of time. The climatic data, including precipitation and the temperature that we obtained from the Spanish meteorological agencies. The seasonal vegetation index, which is just one image per season, that was derived from the planet, and we also computed the interseasonal vegetation index, which is NEDVI. Forest structural attributes, including canopy cover, canopy density, tree heights, are also obtained from PANOA, which was conducted in different time, 2017 and 2019. When I come to the modeling, we've actually followed two-step approaches to develop the model. The first one is selecting the variables based on the random forest algorithms. And then we fitting the models by using 17% of our data sets in this case. And the best model is selected based on the criteria like R-square, IKK information criteria. And simultaneously, we also validate our models by using 30% of the data sets. And the model to validate the matrix that we used is R-square, root mean absolute error, and the root mean square error. And again, we also do the test the residual distribution to know whether it is normally distributed or not. So when I come to the results, we computed the variable importance for different categories. The first one is NEDVI difference between autumn and summer is the most relevant variable from NEDVI category, and the total precipitation over previous 2 years is the relevant variable from climatic category, and the tree height was most relevant from structural category. We also computed by combining all these categories and to see which is the most relevant. And again, NEDVI difference between autumn and the summer was found the most relevant variable to predict mushroom yield. Here we tried to combine different possible combinations to develop the models, and the best performing model is the model that combine the variables from vegetable condition and climatic variable and forest structural variables. Accordingly, the model 5, which explain the most outperforming models among the others. So I tried to visualize the best performing the GAM models, which is generalized additive models. So as we observed from this picture, almost precipitation and tree height have a linear significant relationship with the mushroom yields, but the rest one have non-linear significant effects on the mushroom yields. When we see the interactive one, the reddish one is when the interaction has positive effect on the yield, and the bluish one is the place where the interaction have the negative effects on the mushroom yields. So this is the residual distribution of the top 3 best performing models, and so it fitted about 64% in case of the model 5, and 36% in case of model 6, and 41% in case of model 7. These are the top 3 best fitted models. And to conclude, any DVI difference is the top important variables. Integrating intra-annual vegetation condition in the model improves the predictive capacity of the yields, as well as integrating high spatio-temporal resolution remote sensing provide the promising result in predicting mushroom yields. So for suggestion for future, anyone who want to work to improve the yield predictive capacity, it's better to improve the temporal resolution and include more environmental variables to improve the prediction capacity. And again, species-specific model is also very important to see. And finally, maybe it's upgrading to landscape level is also another important issue. Thank you.
Thank you, Tamiru. This was the last presentation of the day and the Congress. Congrats to all the speakers. You did all good presentations. Now is the time for questions. I think we have like 10 minutes if you have any question for our speakers. Alba has the microphone, so raise your hand.
Hello, I would like to ask a question to Anna. First of all, nice presentation. Congratulations for all the work has been done. My question is, how did you have some damage of your plots caused by the animals, wild animals or domestic animals in the area? On how do you manage this factor? Thank you.
Thank you, Jose. This pasture, there is a grazing use of horses and cows, but we are not measuring that parameter in this work. Besides, the plots we sample are natural plots, like they are not fenced or nothing like that. Like they are normal, natural shrubs that came there naturally. So we are not measuring the grazing that obviously is affecting the herbaceous layer in this study in particularly, but in other studies we are also studying also the synergetic effects of shrubs and grazing that sometimes have on the herbaceous vegetation too.
Thank you. I have a question for Tamiru. Regarding your model, you say nothing about if you test the hypothesis underlying the models. I'm wondering that maybe you have some zeros in some years. If the control, the part of the data that used to fit the model and the data that you reserve to test the model, both are similar in terms of the data distribution, and if you test it, then the lagging hypothesis of the general additive models, or maybe you think that there are other models, other approaches that are best suitable to fit this kind of data.
Okay, thank you. Actually, we tried to fit different models, including linear mixed effect models, and again, even generalized additive mixed models to see which is better to predict the mushroom yields. Unfortunately, those models are very less performant when we compared to the generalized additive models. And then finally, we selected the generalized additive model in that case.
I think that I didn't explain well my question. It's not that you tried others and the performance was better or worse. The problem is that the models that you are using, the methods that you are proposing or testing, are based on some underlying hypothesis. And I think that to be sure that your method is the best one, or at least is suitable, the first step is to show that the data fulfill the expectations to use that model. And I suppose, I don't know your data, but I'm pretty sure that you have several zeros and several moments of the seasons of the mushroom gene production. And then when you have a lot of zeros, there are a lot of different methods that are not GAN that you can use. And also when you are separating the data, I assume that randomly between fitting and testing data, you have to be sure that the distribution of the data are equivalent. And then if you did that, I think that in the presentation, this part is lacking.
Yeah, and even first we tried to do the distribution of the data, and finally we try the data is not normally distributed actually, and then we applied the square root transformation to normalize the data, and we did that one also before come to the model, and that is a reason because that is a reason why we selected the non-parametric test, which is not a linear. So the distribution is not normal, and then we tried to transform the data.
Thank you. First of all, I would like to congratulate all the presenters for their presentations. That was very clear. I have a question for Franklin. Yeah, you used this method to distinguish, or to discriminate between two species that they have already the shapes already different, quite different between each other. And the model gives you a good result. Can you say anything about if you use two species in the same, for example, two broadleaf species, about the accuracy of the discrimination of the model?
Okay, thank you for your question. I use the preliminary results for both species. First of all, the disponibility of the data on the field in Soria, and another reason was the mix them of the forest and the Quercus and Pinus. An additional was a preliminary study to evaluate the performance of the algorithm. After that, we has been planning to do some more settings to the algorithm to try to evaluate this performance in another scenarios, with another species, with another configuration, how was a number of points, number of the rotations, and this kind of settings to evaluate the algorithm. I answer your question or not?
No problem. I was asking if, for example, if you use Quercus pyrenaica and Quercus sicile, the model will be probably not really, I would say, accurate, but should it's practically the same case.
I know, but the first reason for this work is to how I say it, the performance of the algorithm. But I will try to evaluate if the Quercus faginea or Quercus pyrenaica, how the performance of the algorithm. But the first time is to evaluate the algorithm with the same, not the same the shape of the very different for us. If we are to the file is the same to see the difference of the Quercus and the Pinus, but we need to transfer this information to the machine to know how different both species. But after that, we need to try to apply some settings to evaluate with a species that the characteristics are the same, for example. But it's a next steps for our study.
Okay. Another small question for Maria Encarnancia. I just want to know how many climatic variables you used for the PCA analysis.
Have a lot of, for this reason, temperature maximum, medium, minimum of the cold months. There are a lot of, for this reason, we chose a PCA. The first analyze, the more important variables are the precipitation of summer and the temperature means of the cold months.
And last question for Anna. Why you specifically use the TCA analysis instead of other kind of analysis for this study?
Because it's all species cover, so it's the same unit. For example, we perform a PCA too, but with variables, soil variable, because every parameter of soil have a unit to standardize the unit. But for a DCA, for what I know, you can perform a DCA with this data that is all percentage cover of species.
I have one question for Mohammed, and my question is the carbon dioxide emission, they will indicate like 30 million, the emission, and is it per seasonal or maybe from, if you indicate like the duration of this number?
So basically we were comparing fire and the emissions of carbon dioxide. So 13 million is per annum. Annually, like you can say how much carbon dioxide is being produced by natural fire, how much carbon dioxide is being emitted by bush area, by agriculture land. So we accumulated all carbon dioxide for whole nation, and figure is near to 13 million tons per year. Thank you.
Okay, I think we don't have more time for questions. I don't know if there is one last. I don't think so. So I want to give an applause to all the speakers. They did really good. And with this, the season 5 is over. Thank you.
We are almost at the end of the conference, but this section is the most important one, the awards. So we have 2 awards, one for the Best Poster Award and the other for the Best Oral Communication Award. So I call Fuad and Elena, please came here with the 10,000 euros.
So, hello. Come forward. I still remember the first time I took a microphone to address to an audience like you, with many people speaking English. My first time I was so nervous that I listened to my heart much more than to my words. So I perfectly understand that you make a big effort in extracting the best points of your work, of your research, organizing it, supporting it with graphics, and preparing speech that can be understood by very large people from different countries, different scopes, and different subjects. And so for me, all of you have already a beautiful award. And I ask a clap for all of you. I suppose, and I would like to think, that all the courses that we give to you in oral presentations and so on are worthy, because we can see the evolution that many of you did from the very first time you came here. I think now of Eric, for example, that was here for several years. I don't know how many of them. But the first time he was not so natural. And now his presentation is beautiful, very easy to understand, and we are proud of you in seeing your evolution. But we have to choose one winner. And in this case, the winner is not only following all the instructions, all the directions to organize and to present and to repeat and to practice and to so many things, but also the winner included connections with other presentations. And that's something more than what we asked. And the other thing is that the winner is answering very quickly and very clearly, accurately to the questions he or she was addressed. I already told she was someone. The winner is Tiara Zimmerman. Please. I want to ask you to open the prize, because I don't know what's inside this bag. $1,000 million.
Okay? Yes.
I have to practice much more my English because it's not here.
Okay, it's now the turn for the poster. And as Elena said, you are all winners because you did much more work. Try to make things clear in your posters. Try to, summarize the principal results of your work. And we saw in the posters that were very clear and very, efficient. I'm not going to keep telling things, and I'm going to ask to call the winner of the poster session, Seiwa Munera. Seiwa Munera. for the work Resilience and Productivity in Pure and Mixed Forests, a multivariate analysis of vulnerability to disturbances. Congratulations. Then open it.
Okay, so before. Yeah. We are waiting a minute.
We are waiting for the dean.
For the dean, yes. There we have. So just before we close the session, I would like to thank all of you being part of this event, and especially to our speakers for their excellent contribution. Unfortunately, this year we were not able to meet fully in person due to the weather conditions. On the bright side, this also gave us the chance to meet some lovely pet cats online. Okay. I would also like to thank all our chairperson, the organizing volunteers, whose work has been essential in making this event possible. Elena Hidalgo, whom we refuse to let retire, Irene González, Sayoa Munuera, Clara Cámara, Andrea Fadón, Encarnación Coca García, María Martínez Jauregui, María González Granados, and Pilar Balbuena. For those of you who will soon live in Palencia without having had the chance to try patatas a la importancia, we hope you take the great memories with you and that you will come back soon to try them. And now I would like to give the floor to our closing panel, Jorge Martín, as the Vice Rectorate of the Palencia campus, Luis Miguel Cárcel, Director of the School of Agriculture Engineering, Felipe Bravo, Director of the Institute of Sustainable Forest Management, and Pablo Pintor as Coordinator of our doctorate program. Thank you so much and see you all next year.
Thank you, Jonathan. I want also to express our gratitude as Institute to all of you for your participation, especially to Jonathan and his team who coordinate and manage as the last years this event, and we are really happy with the performance. We hope that all of you, besides offer your knowledge, learn something about your peers, and also to be trained for the experience, because this will be only one of the several presentations you will do in the future. Of course, not all of the works are perfect. Never there are perfect work. Not all the speaker speaks perfect English. Not all the speaker did perfect analysis, but I think that this is part of the training. So I think that this is one of the things that we have to work constantly. Even when you arrive in 20 years or in 30 years at the end of your career, still you will need to think that is a space for improvement. If not, then you will not a real scientist in that case. Thank you so much for being here this edition. And now I give the floor to Pablo Martín Pinto, who is the coordinator of our PhD program.
Thank you, Felipe. I was preparing this speech the whole week, so hopefully. Well, so in this kind of meetings, I would like, as director of the, as a coordinator of the committee of our doctorate program, I would like to highlight 4 ideas And finally, a final thought. First, what you can get from these kind of meetings. Scientific excellence or scientific curiosity. I think you that are who are under the master programs, different master programs, or you are starting your PhD now, or you are in the middle of your PhD, or even finishing that, or even just finished, like Eric, who is there. Yes, he presented his PhD 2 days ago. So all of you can get in this meeting this curiosity, just to increase, to improve your curiosity. Well, this kind of things, no? So this would be the first one, no? Just to increase, to get a curiosity to interchange these experiences. The second, the collaboration and the networking. I think, I don't know how many you are, how many countries you are coming from, but this is a super, super special moment for many of you who are able to find people from, I don't know how many countries, so this is something really special. You can see how different people from different places also think, but also how many things you have in common. So I think this is super important for you, not just under the professional point of view, but also under the personal point of view. Also, the personal and professional development. I was remembering when the GONFA the other day give for the Math for Students some key words, key steps for your research development, linking these ideas with ODS, no? So how this is important under the professional, but also under the personal point of view. And finally, the responsibility you have, learning from each other, sharing with each other. So this is not just to use, but also to share, also to have to take this responsibility and then to work by yourselves. And finally, as coordinator of the program, even if you are just thinking of starting your doctorate, or you are starting the doctorate, you are in the way, we are here. Before I was with Valentin, so the committee is always opening our arms for everything you need. So of course, any of you who starting now your career will be more than welcome, and any of you who needs our help or our support, you will be always more than welcome. We will try to do our best. I know it's challenging, it's difficult, but we will do our best. So thank you.
Good morning, everybody. As director of this school, it's a pleasure for me to be in this cluster. 20 years, the 20th annual Young Forester Researchers Meeting, and I think that it's an important milestone to be here 20 years organizing this kind of meeting. I want to express my sincere gratitude to everybody that made this event possible. Mr. Felipe Bravo, Jonathan, Elena Hidalgo, and everybody from UFRO. And I think that you have enjoyed these days, you have shared ideas, research, but you have been living here in Palencia, knowing one to the others, and I think that this meeting has not only been a space for scientific exchange. I think that it's a place to build connections, to improve your experience as a person and in your life. And I think that you will be so proud of being here, and I hope that you will be here next year in our next meeting that I think that Pablo is going to prepare. I hope you have eaten patatas a la importancia, lechazo, and so. But I wish you all, everybody, continue your success in research and your professional journeys all along your life. Welcome to Palencia. Congratulations for being researchers in forestry, and thank you of being with us in this school that is your school now. Thank you to everybody.
Good morning, everyone. First of all, I would like to thank UFOR and especially the organizer for making this meeting possible. If you are not working very hard during probably the last weeks, it is not possible, for sure. Well, we are here today for the closing of this meeting. I know that this meeting was carried out for the last 2 decades, and this is the best indicator of the importance of this meeting in the forest research field. And this is something that we have to be very proud of, because it's relevant, not only here at national level, even in an international one, and we can see very student for Medford that probably is your first contact with our country, with our campus, and I hope that it was a really good experience for you. It is a double pleasure for me to be here in this closing session, because for many years I was sat there in this side of the room, because I was a researcher in forestry field as well, and now I am not longer so young, and now it's your turn. I am confident that this meeting was very fruitful for you, and probably you shared your work with your colleagues and receive feedback that is really important for you, because your new ideas is not coming for you, are coming for your colleagues. That the important thing is that the positive and constructive criticisms, no negative one, okay? Finally, I don't want to go any longer, but I want to ask you to be the best ambassador for our campus in your institutions and your countries. Thank you so much.
Lunchtime.